Hey guys, John Grimsmo here, bringing you a cool project that we've been working on. So, right now, Steven over there is running the Nakamura, making our pen tubes for our Saga pen. Cha-ching! Now with this pen, we used to buy actual tubing, but we weren't super happy. The grade of tubing was different than what we like, and the surface finish on the outside from the factory, from the tubing making factory, was not the best. So we wanted to use precision ground, centerless ground tube that I have to buy for the Swiss lathe, because the surface finish is really nice, great diameter, and we want to drill it from rod. So we've been setting that up. Angelo did all the heavy lifting on that. We got a 15 times D OSG drill that's plowing through and making that hole. They're turning out great, except the problem with this clip was we're still only making one at a time, because we don't have a good reliable way to inject the tube without scratching it into the parts catcher. So basically every 3 minutes Steven is opening the door, grabbing the next one, and hitting go again. So I've been racking my brain trying to come up with different ideas and asking friends and stuff, and I had an awesome suggestion from Andrew Strock, where he said we go through that all the time, and what we do, he showed me his pics and everything, is we do this. So I got a based on his suggestions, I got a gas cylinder, a gas spring from McMaster car. It's cool. It's like 12 bucks. I had my buddy Matt Mittler make me, I designed these in Fusion, just going on the specs of the cylinder, and I drew it all up. I had a collet that I drew up. I drew up a little tip that goes on the top that's the same or smaller diameter than the tube, and this threads into the back of a 5C collet. So I was like, I could make that. It's a relatively simple part, but Matt could also make it, and he's a way better job shop than I am. So for just over 200 bucks, he made me these two things. I'm super happy. Turn them around really quick. They got 3 little set screws that set down on the thing. The spec of the McMaster cylinder, it actually, so I've designed this based on what the website told me of this. Get them together, they don't fit. So we had to scrape the paint off of the outside of the McMaster thing. And now it fits great, fine. So the theory now, there's a couple cool tricks to this. So this guy goes together. So basically, this will be in the sub spindle, and the tube will be finished, and then this will compress. It's hard to do it, awkward to do it right now. Anyway, as the sub spindle comes in and grabs, it's going to compress that spring, and it's going to grab onto the part. It's going to be sprung. It's going to do the threading on this side, and then what we're going to do is we're going to move the B-axis, the sub spindle, forward to the next bar, which is going to be a flat, solid. It's going to butt up against the bar. The collet's going to release. The spring pressure is going to gently hold it in place, and as it backs off far enough, this thing's just going to fall beautifully into the parts catcher. That's the goal. So over the next few days, I'm going on vacation right now, but over the next few days, next week, Angelo and Steven, they're gonna install this thing, they're gonna test it. Angelo's already gone through the code and tweak things up to make it do what he needs to do. So hopefully by the time I get back, this thing's gonna be rocking. Because we're gonna make so many more parts in a day having it automated versus not. I'm looking forward to this. So the funny thing is, on that Nakamura that I almost forgot about, but as we were testing it, trying to find out where the eject position is going to be, where the subspindle comes in. Actually, this is the parts catcher, where the subspindle comes in and drops the part. There's some safety in the machine that if the subspindle is clamped, it won't let it go so close to the main spindle because it thinks you're going to crash. So it needs to go to here, but it only goes to here, and then it just stops until you release the subspindle, and then you can move it forward. There's some unlock code. I've used it before. I just can't remember what it is. So I've got to text in with my my apps guy Kevin. He probably knows this off the top of his head what that is. I'm just waiting to hear back. Once we have that, then we can fully automate this process. Ooh, these parts ejectors are working so good. Let's check in with Angelo and see how the tubes are coming. All right, so how's the ejector going?
It's going pretty good.
Yeah.
Oh my God, what's happening? It's going good. We're about to see it right now. So, took a bit of, we tried to get the machine to drop it off and to use the face of the previous part or the next part.
Yeah, trying to get, this is the new part, trying to get it to come forward and touch, and then it can release and spring pressure back. But yeah, there was like a machine parameter error that wouldn't let the subspindle come in all the way.
Yeah. Even trying to override it back in the ladder, it just won't allow it to happen. So we figured out a spot that it works perfectly, and it works. It's good. You're about to see it.
Yeah, so you'll see it in a second, but it just kind of dumps it slowly into the bin. We expected it to shoot out and fly all over the place, right? But
perfect.
Yeah, because the gas spring, it has a slowness to it. Yeah, so we'll clean the window.
Yep.
Nice. That's faster than I thought it was, actually.
Yeah, we dwell a little bit just in case it hangs up.
Yeah, yeah, and you add some, G4 dwells, which can dwell for like 1 second or half a second or whatever.
Yeah, I was worried that the load, maybe you'll edit it so that they see the...
Yeah, I'll show you the grab next.
Yeah, it's basically compressing that spring. It is, feels like it's a bit of tension, but...
It's a heavy spring, like you can't really comfortably push it with your hand.
So, my concern is the load, but because there are torque alarms, but it's within that spec, so it works out.
Nice. Steven's over here being a boss, drilling holes in the wall.
Secret project.
Next project video.
Pen makes who?
Just tell them what you just told me.
All right. Yeah, one of the reasons we want to integrate our own drilling in this rather than using the seamless tube we were using is that we can use different materials. Right. So we buy centerless ground stock, and we're making that hole ourselves with a 10 times diameter drill. Allows us to use cool materials like that, a little bit of brass testing. We'll try some nickel, aluminum, bronze to match the slider in the future.
Copper maybe?
Copper. Yeah. It'll also allow us to use some of the exotic materials at some point. Maybe. Yeah. Depends on setup. But yeah, that'll help us explore different possibilities for materials.
Yeah, because before we were using a grade 9 titanium tubing. Apparently they can't make grade 5 titanium tubing because it doesn't flow like grade 9 does. It cracks or whatever. And all the other parts are grade 5, so they don't anodize exactly the same. So you do purple, and it's like dark purple and regular purple. Just wait for Steven there. Yep. Yeah, but now that we're doing our drilling instead of buying tubing, and we're buying centerless ground stock, so the outside finish is amazing.
Yep.
Good. Working hard. There's less scratches in the material because it's all ground. It's rounder. It's better. It's gooder.
Yeah.
And
same chemistry, so same anodizing.
Yeah, exactly. And we found source for centerless ground like the copper, the nickel, aluminum, bronze, whatever we want, brass if we want. Yeah. So we'll start stocking that.
Try some new things.
And then, how many have you made now with the new ejector, and how much easier is it?
We've done about 500 tubes now. So before we had to have somebody manually take them out.
Put it this way, we've made, what, 600 pens ever?
Yeah.
And you just made 500 more tubes in the past
2 weeks. Yeah. 2 weeks, including setup.
It's good.
So yeah.
It's really good. Yeah, it's one more step on this lathe to have it more automated. And then you start thinking of things like a bar feeder or bar loader. because you get 10 parts per bar, right?
Yep.
And then half an hour it runs, and then you come in, put another bar. Imagine if it just kept going.
Yeah, like we'll still have to track tolerancing, especially on the threads.
For sure.
That's what moves the most. So we kind of dial it in once this machine's warmed up. It's about 30, 40 parts. It'll maintain that thread, and it'll change a little bit. Just chase it. We'll be able to get some data on that and know where to check it, what to check, how often to change tooling, and
some of the chips wrap up. You got to get in there and pull them out. It's the same thing on the Swiss. Like, before you buy the lathe, you're like, I'll get the bar loader, I'll put in 100 bars, I'll just run it for 5 days straight, and I'll be good for a year. It doesn't work like that in real life.
3 crashes later, and
exactly.
a bunch of mistakes.
Tools wear out, chips wrap up, you run out of coolant, tools break. There's so many variables to machining, and we like that. That's the fun part of it, but it's never as easy as you hope it's going to be.
Yeah. But you prepare for that. You mitigate all the risks you can, and dive in.
Exactly. So yeah, and now this is dialed.
Yeah, this is perfect. Now on to the next.
Love it.
On to the next part.
So this machine basically is dedicated. Let me see your pen.
Yep.
It does tubes, the pocket clip, and the slider, the little collar that goes down. And that's all that we do on this machine.
That's all we do.
And the Swiss does everything else.
Yep. Coolant's okay?
Yeah, it'll splash at the end. So just there you saw it do a double grab. It goes a little bit because the part's not sticking out fully. So it grabs a little bit, it pulls it back, and then it re-clamps and re-grabs again, and then cuts it off. And that works great. All right guys, thanks for watching this little project video. We got a lot more project videos going on. These two machines are almost running. We got a whole cooling system we're working on. That's a whole nother project. Rasks are coming along great. I just haven't filmed anything. Torno stuff going great. Everything's going great. But lots to come. We've just been slammed. So hope you guys are good. Take care. Bye.